Alright, so we're looking at a solutions video to this review for some word problems and sequences, the Unit 5 test. So here you can see at the top we give you all the formulas to pull from. So it says, when a new baby is born to the Johnsons, the family decides to invest $5,000 in an account that earns 7% interest as a way to start the baby's college fund. If they do not touch that investment for 18 years, how much money will they have in the college fund? So the first thing I realized, it's exponential growth. So it's really an example of either one of these is the same. But here's our, our kind of our banking term. So P being our principal, that's how much you start with. The rate is how much we're growing at, and then your time. So the big thing to keep make sure we realize is that the principal, okay, is $5,000. The rate has to be as a decimal, so it's 7%. So we're going to use 0.07, and our term is going to be 18 years. It's only compounded annually, so we're looking at 18 years. So setting up my function, I'm going to say A equals the principal times the rate plus the 1 to the t. Okay. So then I can go ahead and simplify that a little bit. So one of the couple things I like to do is just realize that the growth factor is equal to the value of the base after we add the 1. So the growth factor in this case is 1.07. So now I'm actually going to answer the question for 18 years. So we're going to say A equals 5,000 times 1.07 to the 18. And from here I'm going to need to get myself a calculator. And so if I go ahead and enter this into my calculator, I'm looking at plugging in this right here, 1.07 to the 18 comes out to this. All right. And then I multiply this times the initial principal, which is 5,000. And we get about $16,899. So after I enter that into my calculator, and I'm going to make some money on that. All right, next one. The local Animal Rescue League is trying to reduce the number of stray dogs in the county. They estimate that there are currently 400 stray dogs, and that through their efforts they can place about 8,000 of the animals each month. Okay. How many stray animals will remain after 12 months? So they can reduce. Okay, so they're saying they're trying to get 8% each month. Okay, so we got to come up with our initial amount. So this is exponential decay. Things are getting smaller, so we're going to use this one here with the minus. So what we're going to say here is, okay, so we need to have an initial amount. Right now they estimate about 400 dogs that are stray. The rate, okay, is 8%. So we have to use that as a decimal. Okay. So eventually I'm going to plug in 12 months into my function, okay, as my input. So I'm basically looking at writing my function as f of x equals 400, and then 1 minus r in this case to the x. So I'll simplify this a little bit. And so this is going to be 0.92 to the x. So my decay factor, which is a good thing to always check for, is 0.92. Right? And you can see here that it is going down, so this should be less than 1, and it is. Okay? So we're looking at 12 months. So what we'll do is we'll do f of 12 equals 400 times 0.92 to the 12th. Enter this into my calculator. 0.92 to the 12th gives me about 0.367, and then multiply that by the 400. And f of 12 is about 147.006. So we're looking at dogs. So we would say, in 12 months, there would be about 147 stray dogs. All right, looking at the last one on this first page here. So that a basket of groceries costs $96.50. Assuming an inflation rate of 1.8% per year, how much will that same basket of groceries cost in 20 years? So they're saying with inflation is purchasing power of $1, so it's a dollar can buy less every year. So we're saying is today we can buy some groceries for $96.50. How much is it going to cost for those same groceries in 20 years? So we need our initial amount. So right now we are starting with $96.50. So this is going to go up. This is going to be inflation. This is going to get bigger. So this is going to be, now be careful because there is a decimal here, but it's going to be, you got to move it 2 spaces, so 0.018. Okay, and eventually I'm going to plug in a 20 for the x. So setting this up, I'm going to have f of x equals my initial amount, 1 plus the rate, which is 0.018 to the x.